Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to multiplying and dividing rational expressions. Because we're dealing with expressions today, we will not be solving for x. When multiplying and dividing rational expressions, technically you're evaluating or reducing or something like that. You're not solving. So let's go ahead and let's go back to a lower level multiplying and dividing ratios. So 2/5 multiplied by 25 over 28. There's a few ways we can do this. And so I want to kind of bring focus to several of the ways so that we can look at what's going to be best for us when it comes to working with algebraic ratios. So one way to do this is to go ahead and 2 times 25, because when you multiply fractions, you multiply the numerator and multiply the denominator. You get 50. And 5 times 28 is 140. So with 50 over 140, that is not a reduced fraction. We can divide numerator and denominator by 10, because whatever you do at the top, you do the bottom, right? And that would give us 5/14. So this is great when we have numbers. However, when we start into variables, this is not such an ideal world. So I'm going to give us a second option of how to do this. So 2 is a prime number, and it's getting multiplied by 25, but 25 is 5 times 5. For a denominator, we have 5, and it's being multiplied by 28. 28 is 4 times 7, and 4 is 2 times 2, so we have 2 times 2 times 7. So if I factor it out of the top and I factor it out of the bottom, like I divide both top and bottom by 2, divide by 2, divide by 2. I can also divide numerator and denominator by 5. Divide by 5, divide by 5. So if it happened in the numerator and the denominator, we just cancel that out. And isn't 2 times 5, 10? So we've technically canceled out that factor of 10 that we reduced by in the first version. So we're left with 5 in the numerator and 14 in the denominator. This is the approach I'm going to be using with algebra. That way we don't multiply something up to like a quartic equation and you have powers of 4 and 3 and 2, and then you got to try to factor it back down to see what everything reduces by. We're going to factor first so that it makes our life easier. So it is multiplying and dividing, so we need to refresh our memory of what a division problem would look like and how to do a division problem. So 3/5 divided by 6/35. So to divide fractions, we actually use a multiplicative inverse, or the reciprocal. Some people learned in younger years to call it keep, switch, see how the dividing switch to multiplying, flip. Okay, so now we have the 3/5 that is being multiplied by the 35 over 6. But 35 is 5 times 7, and 6 is 2 times 3. So I use those prime factorizations instead of writing 35 and 6. And now we can go ahead and cancel. We have a 3 factor that's going to cancel. We have a 5 factor that's going to cancel. And we're left with something simple in the numerator and at the denominator. A reminder, if you cancel everything out, technically there's still a 1. Because technically I could say this is 3 times 1 and 5 times 1 as the prime factorization. So don't just drop off a numerator or denominator. Remember, there's always at least a 1 there, not a 0, a 1. So improper fractions I use a lot at this point in math, so I'm okay with that. So when we learn dividing, it's really multiplying because you use the multiplicative inverse. Okay, now a common mistake I see is, let's say we have x plus 5 over x plus 7. A lot of people want to say this equals 5/7. Well, that's true if x equals 0. But let's see if when x is 1, 1 plus 5 over 1 plus 7, well, that's 6 over 8. That's 3/4. 3/4 is not the same as 5/7. So because this is a binomial, because of the plus sign, technically there's understood parentheses around it. And the same thing with x plus 7. When we canceled before, they were multipliers. 3 times 5 times 7. Why does that work? Well, 5 times 2 over 7 times 2. Let's think about that. 5 times 2, that's 10 over 14, and we've been taught that we can reduce by dividing by 2, and we get 5/7. Now the other thing, is 10/14 equal to 5/7? Well, you can change them both into a decimal and you'll find out it's true. But here they are a monomial. Here they are a binomial. If you look at math memes and the save the animals, I think this is the kitten one. You got to save the kitties. You can't cancel out when you have a binomial. You can cancel out a factor, but you can't cancel out. It has to be a multiplier that's getting canceled out, not an adder or subtractor, okay? So if it's a multiply in the top and bottom, yes, reduce. If it's an add in the top and bottom, no reduce. Okay? So multipliers, yes. Adding and subtracting, no. Okay, so we got to prep for these, okay? As you've noticed, I've been factoring. So prime factorization is a very big deal. I've been using the prime factors of all those numbers. So the first thing you're going to want to do is get a prime factorization. Now, remember the first step for prime factorization is check for that GCF. That's always the easiest one to do. Greatest common factor. Okay? Can you unfoil it? Reverse that FOIL process. If you need to, graph it and see if it crosses the x-axis. If you need help with that factoring, with that possible, you can go back to the polynomial factorizing and rational zeros theorem. I've done some videos on that before. The other thing to note, and this can be a really, really helpful thing, b minus a is equal to -1 times a minus b. So see how that subtracting order switched? So let's do that with numbers. 5 minus 2 is equal to -1, 2 minus 5. Do you agree or not agree? Well, 5 minus 2 is 3. 2 minus 5 is -3. But I said, hey, multiply by -1. I do agree. So remember, when you subtract, if you do it one way, you'll get a positive number. If you do it the other way, you get a negative number. Or 0 if they're the same number. I get that. But that's where that -1 comes in. This little trick is very helpful to us sometimes. And so I see it as factoring out a GCF, factoring out a -1. Okay. You usually, when doing these, are going to be asked about the domain, so you have to identify all possible domain errors. That's also my second step. I always do this before I reduce because the original problem, if it was an error in the original problem, it has to stay an error the whole time, okay? These would also be known as discontinuities. If you were to graph the original problem, it would either have a hole or an asymptote at these numbers. And this happens because our domain error is going to happen because our denominator equals 0. Remember, 0 divided by a number is game on, but a number divided by 0 is a big no. So anytime you have 0 in the denominator, that's a no-no. We can't do that. Okay, after, and that's your second step. After you do those two steps, your third step will be to reduce or cancel. If I have x plus 2 in the numerator and I have x plus 2 in the denominator, those are multipliers, right? Those will cancel. Because again, we can cancel a multiplier. And here, we're not canceling the plus 2, we're canceling the entire parenthesis, which is a product, right? That's why we factor, is to write it as a product or a multiply problem. And then step 4 is to multiply what's left. Now, 3 of these steps we actually did in our numerical examples. The only thing we didn't worry about is discontinuities because we had numbers in the denominator, not variables. So I wrote the prime factorization. I canceled numerator denominator, and then I multiplied what's left. So what we're doing in this video is the same thing as what you see here. We're just going to have variables. Okay, let's go for it. And why just multiply 2 fractions? We're going to go ahead and multiply 3 fractions. So 5 over x plus 3 is being multiplied by x squared plus x minus 6 over x squared plus 2x plus 1, which is being multiplied by x squared plus x over 5x minus 10. And please keep in mind that there's technically parentheses around every numerator and denominator. Okay, they're assumed. You're not going to write it in pencil if you don't have to, because, you know, it's extra characters on the page that they'd have to print in your books and things like that. I didn't put parentheses around the 5 because it's a prime number. So that's what we're going to do. We're going to start that prime factorization. Actually, that's not the problem I wanted. I wanted 5x. I forgot. So sorry about that. Okay, so the first numerator just reads 5 times x. That's already a multiply problem. The denominator is an adding problem, and it has a GCF of 1. I could write it 1 times x plus 3, or I can just write it x plus 3. It is prime. I can't do anything to that. This looks like the personal product of a FOIL problem, like a binomial times a binomial, because it does not have a GCF. So what multiplies to negative 6 and adds to 1? That would be positive 3 and negative 2. And you can go back and watch my factoring videos if you're having trouble with that part. So this is assuming that you know how to factor at this point. So GCF is gone, there's no GCF. What multiplies to 1 and adds to 2? That would be 1 and 1. Again, now we have multiply problems. That's what we need, everything being written as a multiplier. Here in the numerator, we have a GCF of x, which would leave us x plus 1. And here we have a GCF of 5, which would leave us x minus 2. Okay. Remember, when we multiply these, we're multiplying everything in the top, we're multiplying everything in the bottom. So basically, this becomes one big long numerator and one big long denominator. And we could multiply it all together and then reduce, but we're going to reduce first. So here's a 5 in the numerator. Is there a 5 anywhere in the denominator? Yes. So this 5 and this 5 are going to cancel. Here is an x in the numerator. This is a multiplier of x plus 3, x plus 1, x plus 1, x minus 2, so no. I get that there's an x here and an x here, but they're both in the numerator, so they have to stay in the numerator. You can't cancel. Here's an x plus 3 in the numerator and an x plus 3 in the denominator. So a numerator x plus 3 cancels out a denominator x plus 3. Here's a numerator x minus 2 and a denominator x minus 2. So that cancels. Here's that other x. It doesn't cancel because they're both on the top. And here's a multiplier of x plus 1. And I know there's 2 of the x plus 1s, but we can only cancel out one of them because there was only one in the top. Okay, so what is left in the top or in the numerator? We have an x times an x. So the numerator, and in the denominator we have just that x plus 1. So your final answer here would be x squared over x plus 1. Again, there's assumed parentheses around that x plus 1. Now, I forgot one of the big steps. Shame on me. It's okay, we can reverse and get it in. Because this was there, x cannot equal negative 3. Because negative 3 plus 3 is 0. Because this is here, x cannot equal negative 1. Because this is here, x cannot equal negative 1. We already have that. This is a number, so there's no x right there. And because of this, x cannot equal 2. So we have 3 domain errors. I completely forgot to do that step. So here is our final solution. That is this problem, simplified down. And these are the domain errors from the original problem. Depending on your directions, you may or may not have to write that down. Okay. So let's look at one more example because this is really multiplying and dividing, right? So I'm going to do a division problem, which I know that's technically a multiply problem, so it's all right. Okay, so right off, I notice that this is x squared plus 9x. This is the x squared minus the other part. But this has the minus x squared. So this one's kind of written backwards. These are written in descending order and descending order, but this is not. So I'm going to keep that in mind when I'm working on my prime factorization. So I'm just going to do the prime factorizations out, or the factorizations out to the side. X squared plus 9x has a GCF of x, which would leave me with x plus 9. (36 minus x squared). I'm first going to do that GCF of negative 1 so that I can make it x squared minus 36, which is that trick I talked about earlier when I said, hey, a minus b and b minus a, right? Now that helped me switch the order, and then I also know that this is that special conjugate pattern of x minus 6, x plus 6. So I did that one in green. I did that one in pink. 3x squared minus 18x. This has a GCF of 3x, leaving us with x minus 6. Okay, let's pop those in. 1 over divided by. So instead of x squared plus 9, we have x plus 9. And we have 3x, x minus 6. And we have negative 1, x minus 6, x plus 6. Okay, domain errors, right? And remember, there's technically parentheses around this x and around this x. And around the 3 too, but. So because of this first x cannot equal 0. See, I remember to do it first this time. Because of this one, x cannot equal -9. Because of this one, x cannot equal 0. And because of this one, x cannot equal 6. So we have 3 domain errors right now because 0 just occurred twice. Now, because it's division, we have to do that keep, switch, flip, right? Use that reciprocal. So 1 over x plus 9 multiplied by 3x, x minus 6, -1, x minus 6, x plus 6. Uh-oh. Because we did the reciprocal, now we have more discontinuities because we have a new denominator. So because of this one, x cannot equal 6, which we already had. And because of this one, x cannot equal -6. Okay, so our total sum of discontinuities, not sum, but we have 0, -9, 6, and -6. There are 4 things that x cannot be. If you were to use them in the original problem, your calculator would say error, cannot do. All right, so now it's a multiply problem. Now we can start our canceling. I'm not going to rewrite it. I'm just going to go ahead and cancel from here. So the x would cancel the x. The x minus 6 would cancel the x minus 6. So in the numerator, we have 1 times 3. And in the denominator, we have -1 times x plus 9 times x plus 6. Now, most mathematicians do not like to leave a negative like that in the denominator. They like to go ahead and multiply the top and bottom by -1, which 1 times 3 times -1 is -3. -1 times -1 is +1. And then that would be multiplied by the x plus 9, x plus 6. So that +1, do you really have to do that? No, not really. We can erase that right there. So basically, if you have a positive numerator and a negative denominator, they like you either to write the negative in the numerator or write the negative out front. Notice how when I wrote it out front, it's in the middle. Okay, this is an acceptable way to leave the answer. You could also write the answer as -3 over, and then go ahead and multiply that out. Again, notating that your domain errors are what they are, depending on how it words the question. But that's all we're doing. We're just following that process every time. Prime factorize, identify domain errors, cancel numerator and denominator, and then multiply what's left. So make sure that you have your factoring skills down pat, because that will make this much, much easier. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.